Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new lecture. This channel was launched in 2020 to support the Maritime India Vision 2030, an initiative by the Ministry of Ports, Shipping and Waterways. We are currently studying marine boilers as per the revised 2024 syllabus of the Indian Maritime University. Marine boilers is the first marine subject in the third semester of BTech Marine Engineering course under the Indian Maritime University. In this lecture, we will begin by exploring the history of steam propulsion on merchant ships. Next, we will cover an introduction to boilers. We will then examine the layout of marine boilers and its components. After that, we will discuss the difference in production and uses of saturated and superheated steam. We will also compare fuel-fired boilers and exhaust gas boilers used on motor ships. Let's go through these topics in the following slides. History of steam propulsion on merchant ships. First attempt to use steam for propulsion. A French inventor launched the first steam-powered paddle boat in 1783 on the Somme River in France. First commercial operation by steam propulsion. SS Savannah became the first steamship to cross the Atlantic in 1819, although it relied on sails for most of the journey. First steam propelled ship to cross the Atlantic. SS Great Britain was the first iron hulled screw propelled steamship to cross the Atlantic in 1843. Golden era of steam propulsion. Steamships dominated the global trade routes in the late 19th century, offering faster and more reliable transportation as compared to the sail powered ships. First Indian registered merchant ship. SS Loyalty, originally a British vessel known as the RMS Empress of India, was built in 1890 and later purchased by the Scindia Steam Navigation Company Limited. It became the first Indian registered merchant ship and sailed on April 5, 1919 from Bombay to London. Indian Merchant Navy Day is celebrated annually on April 5th to commemorate the historic voyage of SS Loyalty. Use of steam turbines on merchant ships. The steam turbine was first used on the RMS Mauritania in 1906, which represented a significant advancement in steamship technology. Decline of steam propulsion. After World War II, diesel powered ships began replacing steamships due to the better fuel efficiency and lower operational costs. Steam turbines are still used in some naval ships, particularly submarines that utilize nuclear fuel, which offers a unique advantage over diesel powered ships that require air for the fuel combustion. Extension of steam propelled ships. Gas carriers relied on steam turbines until recently, as cargo boil of gas could be used as fuel for boilers. However, steamships are now on the verge of extinction because diesel engines have been developed to utilize gaseous fuels efficiently. Purpose of steam on modern ships. Today, steam is primarily used on merchant ships for auxiliary purposes. Although steam turbines continue to be employed on some conventional oil tankers and container ships equipped with waste heat recovery systems. Introduction to boilers. What is a boiler? A boiler is a closed vessel that contains water which is heated to produce steam. How is steam created? When heat is applied, the force of attraction between the water molecules decreases, causing them to separate and convert into steam. The kinetic energy of these molecules exert force on the walls of the vessel, thereby creating pressure. A large heating surface area is provided to facilitate the quick transfer of heat from the combustion of fuel to the water. All modes of heat transfer, that is conduction, convection, and radiation, are utilized in the boiler. Where is the fuel burnt? All boilers have a furnace or combustion chamber where fuel is burned to release energy. Air is supplied to the furnace to enable the combustion of fuel. The energy released by burning the fuel in the boiler furnace is stored as temperature and pressure in the steam produced. Where is the steam stored in the boiler? A drum is provided to separate steam from water. How are the steam pressure and water level maintained? Controls are provided to ensure that the supply of fuel oil, air, and feed water matches the steam demand. How is the safety and reliability maintained in boiler? A number of mountings are installed to ensure the safe operation of boiler. A smoke tube boiler. The sketch shows a smoke tube boiler which is used for low pressure and low evaporation rate required on motor ships for auxiliary purposes. It consists of a vertical cylindrical drum with dome shaped top. Bottom of the shell consists of a hemispherical furnace whose bottom is lined with refractory material to prevent the heat loss. Flue gases from the furnace flow to the combustion chamber through the flue pipe. A smoke box is formed opposite to the combustion chamber. Large number of smoke tubes are attached between combustion chamber and the smoke box which generates steam in the boiler. Boiler drum is filled with distilled water which surrounds furnace, combustion chamber and all the tubes up to the normal water level which can be seen through the gauge glass. An oil or gas burner is connected to the furnace through the burner tube which supplies heat to the boiler for generation of steam. Flue gases from combustion chamber enter and flow through the generating tubes, collecting the smoke box from where these are discharged to the atmosphere through the exhaust gas uptake. Steam generated in the boiler is collected in the steam space, whose pressure is monitored by the pressure gauge P. Steam passes through the separator to remove entrained water droplets and delivered to the steam pipe from the steam stop valve. Water is supplied to the boiler to the feed and check valve to maintain the normal water level. Boiler is protected from low water level by a fusible plug mounted on the combustion chamber crown. In modern boilers, it is replaced with low water level trip. Boiler is protected from excessive steam pressure by a pair of safety valves mounted on the boiler dome. Inspection covers are provided for maintenance and repair of smoke tubes. Blowdown valve is used to drain the water from boiler. Manhole is used for inspection and repair of steam and water space. Difference between saturated and superheated steam. This model symbolically distinguishes between production of saturated and superheated steam. On motor ships, water is heated in the boiler tubes to produce saturated steam, which is suitable for heating and other miscellaneous purposes. On steamships, the saturated steam obtained from the boiler drum is reheated in the superheater tubes using the flue gases to produce superheated steam, which is used to perform mechanical work with the help of steam turbines. On steamships, superheated steam is desuperheated to produce nearly saturated steam for miscellaneous purposes. Difference between fuel fired and exhaust gas boilers. How are modern merchant ships propelled? Modern merchant ships are mainly propelled by diesel engines, although in the earlier days ships were powered by steam turbines. Other propulsion options include diesel electric systems or gas turbines, which are used on smaller ships. What was the arrangement on steamships? Steam turbine propelled ships were equipped with two main boilers for the continuous generation of steam both in port and while at sea for propulsion, power generation, or auxiliary purposes. How was steam produced on steamships? Main boilers produced superheated steam, which is essential for producing mechanical power, as saturated steam can cause erosion of turbine blades. For auxiliary purposes, steam was desuperheated to reduce its temperature. How is steam produced on motor ships? On the other hand, a diesel propelled ship consists of a fuel fired auxiliary boiler and an exhaust gas economizer. The fuel fired boiler is used to generate steam when the ship is in or around the port. What is an exhaust gas economizer? The exhaust gas economizer is a waste heat recovery unit which generates steam when the ship is at sea by utilizing the exhaust gases from the main propulsion engine. Any shortfall of steam from the exhaust gas economizer is supplemented by the oil fired boiler. Why motor ships don't produce power using steam? Saturated steam is generated by the auxiliary boilers and used for auxiliary purposes. However, operating auxiliary steam turbines is not preferred as it is uneconomical. Types of steam produced by exhaust gas economizer. The exhaust gas economizer typically produces saturated steam, but on some container ships equipped with turbogenerator, superheated steam is utilized for its operation while at sea. Other alternatives of boilers used on motor ships. Some motor ships, instead of fuel-fired boiler or exhaust gas boiler, are equipped with a thermal oil system to meet the ship's heating demands. Working of thermal oil system. Similar to the boiler, a fuel burner is used to heat the thermal oil when the ship is in port, while an economizer is used at sea, utilizing the diesel engine exhaust gases for heating the thermal oil. This completes our study of the history of steam propulsion on merchant ships, an introduction to the boilers, the layout of smoke tube boiler, the difference between saturated and superheated steam, and the difference between fuel fired and exhaust gas boilers. This book has been written by me and covers all the topics as per the Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in the examination conducted by Indian Maritime University. It will help students prepare effectively for exams and also support them in working safely with ship boilers. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends, especially students in the third semester. Subscribe to the channel to stay updated with upcoming tutorials. I'll be back soon with a new lecture. Thanks for watching till the end.